السلام عليكم ورحمة الله وبركاته الأبناء الأعزاء. Let's continue our discussion. Last time بفضل الله we finished the trigonometric functions, 6 functions: sine, cosine, tan, cotan, sec, cosec, and we learned how to make their graph, how to obtain the domain, how to obtain the range, how to obtain symmetry, how to obtain periodicity, and finally how to obtain the derivative. Today inshallah we will go to the inverse trigonometric functions, الدوال المثلثية العكسية. But before we enter these inverse trigonometric functions, we will start with what is meant by the inverse function. ما هو المقصود بالدالة العكسية؟ We already know that if we have some function in the form y equals f of x, this is a relation relates to variables x and y. We call x as independent variable, المتغير المستقل, independent variable, and y as the dependent المعتمد, dependent variable. When we make the graph, we consider x as the horizontal axis and y as the vertical axis. So the horizontal axis is assigned for independent variable, while the vertical axis is assigned for the dependent variable. Also the values of x construct what is called domain المدى, and the corresponding values of y construct what is called range. X has a domain and y has a range. Actually, y is the image of x. We put some value of x as input, then we have the output as y. We must have to be a function. We must have for every value of x one and only one value of y, only one and one image of y. As you see, say this is the domain x, domain, and this is the corresponding range, values of y. Every value in x has a corresponding image or value in y. One and only one value in y. Another value in x has another value in y. A third value in x may have this as previous value in y, no problem. But never one value in x has two different values in y. Okay? This is called a function. Now, the inverse means that we rearrange the given function such that y is replaced by x and x is replaced by y, or we express x in terms of y. Originally we express y as a function of x. But what about if we rearrange the function such that x is represented by in terms of y? This is called the inverse function in the form y equals f minus 1 of x. Not f to the power minus 1, no. This is a notation and it is pronounced y equals f minus 1 of x. This means the inverse function of the original function. In this case, x actually is expressed as a new function in y. This is the original one, this is the inverse one. Okay? But we as we said, if now x is dependent while y is independent, dependent variable, and y is independent variable. So when we make the graph, we must put y on the horizontal and x as a vertical, but we are used to make y as vertical and x as horizontal. So no problem. After obtaining the inverse function, just these are dummy variables. Maybe you write u equals u of v or t equals u of s. So no problem to replace y instead of x and x instead of y, g of y, u of x. So we have the inverse function f minus 1 of x. So now y will have for the inverse function x, as we said, dependent, y independent. So y now has a domain, while x will have a range. Okay, now let us take a simple example. Say we have original function y equals f of x is expressed as y equals x cubed. Okay, as you see, x belongs to R and y also belongs to R. The domain is all the values, real values, and y all the real values, and the graph will be something like this. Y equals x cubed will be in this form. Y equals x cubed. Now for the inverse function, y equals x cubed, or x equals y to the power 1/3. Okay, as we said, replace every x by y, replace every y by x, so we have x to the power 1/3. This is f minus 1 of x. Okay, let us draw this function like this. Still x horizontal, still y vertical. Okay, let us redraw the function. This is y equals f of x. This is y equals f minus 1 of x. Let us redraw the two functions on the same axes. This will be f of x and this will be f minus 1 of x. If you calculated these 2 points, we find them as 1, 1, minus 1, minus 1. Both lies on the 45 line like this. This is y equals x. Okay, as you see, anyone is the image of the other, assuming that y equals x is a plane mirror. واحنا افترضنا y equals x as a plane mirror, so the red will be reflected as the green, and the green will be reflected as the red. Okay, now what about the domain and range of the inverse function? As you see, x still belongs to R and y also belongs to R. Okay, let us investigate another example, but you have to see that every value of x, either in the function or its inverse, has only one and one image in y. As you see, if we draw any vertical line, it will intersect with the graph of the function in only one point. Any vertical line will intersect the graph of the function in only one point. This is called the vertical line test. Otherwise, it is not a function, it is a relation. Let us discuss another example. Say y equals x squared. Example 2. Y equals x squared. Okay? As you see, x belongs to R, while y is restricted between 0 and infinity. Why? Because either x positive negative, y would be still positive. X equals 2 minus 2, y is 4. X equals 3 minus 3, y is 9. X equals 1 minus 1, y is 1. X equals 0, y is 0. This is the least value of y, and it increases up to infinity. So 0 less or equal y less than infinity. This is for domain and range of the given function. Now, what about its inverse? Its inverse, we express x in terms of y. So write x equals y to the power half. Actually, plus or minus. This is not a function, this is a relation. Why? Because for every value of y, you have more than one value of x. For every value of the independent variable, you have more than one value of the dependent one. So it is a relation, not a function. This is a relation. But we want it as a function, so you have to write x either equal minus y to the power half or y to the power half. Let us consider y to the power half or simply root y. Now let us obtain the graph of both functions. Then we draw both on the same axes. X, Y, X, Y, X, Y. Okay? For the first function, its graph is like this. This is y equals f of x equals x squared. Now, for the inverse, as we said, replace every x by y, replace every y by x, so we have y equals root x or x to the power half. The graph of this function is like this. Under the root means x has a minimum value of 0 and more than. It can never be negative, otherwise it will be imaginary. So 0 less than or equal x less than infinity. This is the new domain. This is for inverse function. This is for inverse function. While this for original function. Original function. Okay? What about the range, as you see, also 0 less than or equal x less than or equal infinity. Okay? Now, on the same axis, this is the inverse, y equals f minus 1 of x, and this is the original function. Again, if we draw the line y, y equals x, it will be a plane mirror relative to the original function. This is f of x, this is f minus 1 of x. This is x squared, this is root x. And as you see, both are the original photo and our original picture and its image relative to the y, the line y equals x. Okay? But we have to discuss something here. In the first example, we don't have the problem of plus or minus. The function and its inverse were directly single valued, as they must be. But when we try to obtain the inverse of y equals x squared, we have a multi-valued relation. Not function. The function, as I told you, using the vertical line test, we must have, for every vertical line we have one and only one value. For any vertical line we have one and one value of the function, so it is called a function. Okay, now we have two values. What we have to do, we have to choose one of them called the principal. Actually, the other part of this relation is like this, downward. Have plus or minus, positive, upward, negative, downward. But this is not a function. This and this are not a function. Only this branch or this branch. We have to choose only one branch of them. In this example, we already have chosen y equals positive root of as the principal branch. This is called principal branch, الفرع الرئيسي. This is very, very important in studying the function and its inverse. Let us clarify this with a third example. Say we have y equals 1 over x squared plus 1. This is the original function. This is f of x. Okay? What about its inverse? Before, let us obtain its domain and range. As you see, x, no problem for x, belongs to R. Positive, negative, 0, no problem. But if there was x squared minus 1, no, there is a problem. We can't accept x equals 1 or minus 1. Why? Because it causes denominator to be 0. But x squared plus 1, there is no problem for x to be positive, negative for any value of x. But what about y? As you see, as x increases or decreases in negative values, x squared increases. x1 or minus 1, 2. x3 or minus 3, 10. x4 or minus 4, 17. So as x increases, y decreases. As x approaches infinity or minus infinity, y approaches 0. As x approaches 0, y approaches 1. This is the maximum value of y. So y is bounded between 0 and 1. Okay? when y equals 0 as x approaches infinity. So y is not equal to 0. It will approach 0 as x approaches infinity or minus infinity. So for our range, we write 0 less than y less than or equal 1, because we can reach actually 0, but when we reach infinity, when we reach minus infinity, no answer. So we can't put an equal sign here with the 0. Now, how is its graph? As you remember, as x approaches infinity or minus infinity, we have what we call a horizontal asymptote. But when x approaches infinity or minus infinity, y approaches 0. Y approaches 0 is the x-axis. So the x-axis actually is a horizontal asymptote. As you remember, we put dotted line very, very close to it. So our function approaches 0 as x approaches infinity or minus infinity. And when x is 0, our function has its maximum value, which is 1. So this point is 0 and 1. So our function is like this. Okay? Now, what about the inverse function? Y equals f of x, y equals f minus 1 of x. For the inverse function, we replace x in place of y and y in place of x, or we not direct replacement, but we express x in terms of y. How? We can obtain the reciprocal of both sides, so we have 1 over y equals x squared plus 1, or x squared equals 1 over y minus 1, or simply x equals plus or minus square root of 1 over y minus 1, or simply 1 minus y over 1 plus or minus. Still multi-valued function. As we did in the previous example, we take only one branch. It has two branches, positive branch, negative branch. Okay, let us take the positive branch. So we have, as for the inverse function, y equals square root of minus y divided by y. This is f minus 1 of x. Okay, now let us draw this function. As you see, y can never be more than 1. Why? If y greater than 1, you will have a negative value under the square root. This can never be done for real values. So y must be less than 1. Okay? Y less than 1. Maybe 1, no problem. Why? If y equals 1, the numerator will be 0, the numerator will be 1, so no problem. But also y can never be 0. Why? If y equals 0, this will make the whole root 1 minus 0 over 0, which is infinity. So as x is as well as now we have, as I told you, we just write y instead of x instead of y. So our inverse function is in this form. So x can never be more than 1. This is a domain. This is a domain. X can never be more than 1. but less or equal 1. And it can never be 0. It can never be 0. It's 0 just before 0 or 0 plus. Okay, so but can x be negative value? No. Why? If x is negative value, actually numerator will be positive, but denominator will be negative. Positive over negative is negative. We can't have a negative square root. So the minimum value of x is 0, but never equal to 0. This is the domain. What about the range? These are the limits of x. What are the corresponding limits of y? When x is 1, y is 0. When x is 0, y is infinity. Well, 0 plus, 0 plus. So the range will be 0 less than y, 0 less than or equal. Why equal? Because we can set x equals to 1, as you see. And when x approaches 0, y approaches infinity less than infinity. Okay, so y is bounded between 0 and infinity, x is bounded between 0 and 1. So the graph of y is 0 at x1. So this point 1, 0. Okay, as you see, every point in the original function will be reversed for the value of x and y in the inverse function. 0, 1, 1, 0. 1, 2, 2, 1. Half, 1/3, 1/3 half, and so on. As I told you, the function and this inverse are the image of each other around y equals x. So any value has its image around y equals x by reversing the positions of x and y. If x equals 2, y equals 3, it's as relative to the y equals x, x2, y will be 3, or equals 3, will be reflected to 3 and 2. Okay? So the graph will be something like this. And x equals 0 is a vertical asymptote. X equals 0 is a vertical asymptote. Horizontal asymptote is transformed to vertical asymptote. Why? Every value is reversed to the other. Now, on one set of axes, as you see, is f of x f minus 1 of x we don't complete this part because we take, as we said before, a principal branch. This is our principal branch. This is our principal branch. Okay? And this is the original function. As you see still, they are the image of each other around y equals x. As you see. اوكي ان شاء الله نتقابل في المحاضرة الجاية لما نيجي ندرس ان شاء الله the inverse trigonometric functions. والسلام عليكم ورحمة الله.